Just to find out the distance, use the distance formula, and to find the area, use area of a triangle formula. Assumes all the values of x which are lesser than or equal to x. The values which are less than or equal to x is called the greatest integer function, right? The length of perpendicular, you know the formula for length of perpendicular is ax1 plus by1 plus c divided by root of a square plus b square. Hello dear students, welcome to this session of mathematics question paper discussion. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important part, that is part D, all 5 marker questions. So part D, in this part D you are going to answer 4 questions, each question carries 5 marks. So answer any 4 questions, each question carries 5 marks. So 20 marks from this part D. So let us move on to the first question. Define the greatest integer function. Greatest integer function. Draw the graph, write the domain and range of the greatest integer function. This is very important question. So first define the greatest integer function, then draw the graph of greatest integer function, domain and the range. Now, how to define this greatest integer function? So, a function f from R to R, a function f from R to R, a function f from R to R is defined by f of x is equal to x. This is called greatest integer function for all x belongs to R. So, which assumes all the values of x which are lesser than or equal to x. So, all the values less than or equal to x, less than or equal to x. All the values of x which are lesser than or equal to x is called the greatest integer function. So, a function f from R to R is defined by f of x is equal to x for all x belongs to R, assumes all the values of x which are lesser than or equal to x. The values which are less than or equal to x is called the greatest integer function, right? This is also called as the step function because the graph seems like a steps. So this is the graph for the greatest integer function. Therefore, the greatest integer function is f of x is equal to x belongs to R, right? X belongs to R. So this is called the step function. The graph of the greatest integer function is just like a step. This is the graph for the greatest integer function. Now, what is the domain and range? So the domain of this greatest integer function is R and the range is equal to Z. The domain is R and the range is equal to Z for this greatest integer function. Okay. So this is how we are going to write the graph of greatest integer function. The domain is R and range is equal to Z. Now move on to the next problem. From trigonometry, prove that sin 5x minus 2 sin 3x plus sin x divided by cos 5x minus cos x is equal to tan x. Now let us take LHS. What is LHS here? Sin of 5x minus 2 times sin 3x plus sin x divided by cos 5x minus cos x. Okay. Now let us group these two terms. Make a group of sin 5x plus sin x, one group, and minus 2 times sin 3x as it is in the numerator. Denominator, this is same, cos 5x minus cos x. Now if you observe carefully, the numerator sin c plus sin d, denominator cos c minus cos d. Now what is the formula for sin c plus sin d? 2 sin c plus d by 2 into cos c minus d by 2. So this is equal to 2 sin c plus d by 2, 5x plus x, 2 sin c plus d by 2 into cos c minus d by 2 minus, this is same, minus 2 sin 3x as it is, whole divided by, in the denominator we have cos c minus cos d. What is the formula for cos c minus cos d? So it is minus 2 sin c plus d by 2, minus 2 sin c plus d by 2 into sin c minus d by 2. Right. So this is equal to 2 times sine 5 plus x is 6x by 2 is 3x, sine 3x into cos of 5 minus x is 4x by 2 is 2x, minus this is same 2 sine 3x whole divided by in the denominator minus 2 times sine 5 plus x is 6 by 2 is 3x into sine of 5 minus x is 2x divided by 2 is 2x. So you can take the common factor in the numerator, you can take 2 sine 3x common factor, and what is left is cos 2x minus 1 divided by in the denominator. So you can take now in the denominator minus 2 sine 3x into sine 2x. So cancel the terms, 2 and 2 gets cancelled, sine gets cancelled. So what we have, this is equal to cos 2x minus 1 divided by minus of sine 2x. This is equal to, now so what is the answer we want to get? It is tan. Now convert numerator in terms of sine and denominator in terms of cos. So cos 2x can also be written as 1 minus 2 sine square x minus 1 divided by minus sine 2x is nothing but 2 sine x into cos x. So here minus 1 plus 1 gets cancelled. In the numerator we have minus 2 sine square x divided by in the denominator minus 2 sine x into cos x. Cancel the terms. Minus 2 sine x in numerator and denominator gets cancelled. What is there? Minus sine x in the numerator, in the denominator cos x. Sine x by cos x is equal to tan x, which is the required RHS. That's it. So just cancel the terms. Cos 2x can be written as 1 minus 2 sine square x. Cos 2x is equal to 1 minus 2 sine square x minus 1. Minus 1 plus 1 gets cancelled. Sine 2x is 2 sine x cos x. Minus 2 sine x gets cancelled. In the numerator, sine by cos is tan x. That's it. Hope you followed. Okay. 5-marker question. Now move on to the next problem. Find the number of arrangement of the letters of the word independence. In how many of these arrangement do the word starts with P and do the words begin with I and ends with P? There are two conditions. So do the words start with P and do the words begin with I and ends with the P. Now what is given? Independence. So just find out how many letters are there. So independence, this contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it contains 12 letters. 12 letters in which how many I are there? Just find out first N. 1, 2, 3. 3 N's are there. Then E. How many E's are there? 1, 2, 3, 4 E's are there. 4 E's. Right. Then D. 1, 2. 2 D's are there. So 3 N's, 4 E and 2 D's. Remaining are all 1 term. So I 1, remaining I, then P, then C. All 1 term, 1 numbers each. So totally 3, 3 plus 2, 5, 5 plus 4 is 9, 9 plus 3 is 12. So 12 letters are there in this word, right? Now, so there are 12 letters of which N appears 3 times, C appears 4 times and D appears 2 times and the rest all different or 1 time. Therefore, the required number of arrangement is total number 11, 12 factorial divided by 3 factorial into 4 factorial into 2 factorial into 1 factorial. That's equal to 166320. 1663200. So that is unit 10, 100,000, 10,000, lakh, 10 lakhs. So that is 16,63,200. Now first condition. What is the first condition? Do the word start with P? So let us fix P at the extreme left position. We then count the arrangement of the remaining 11 letters. Therefore, the required number of words starting with P can be written as 11 factorial divided by 3 factorial into 2 factorial into 4 factorial. So 11 factorial divided by 3 factorial into 2 factorial into 4 factorial. That's equal to 1,38,600. So the words we start with P is 1,38,600. That is 11 factorial divided by 3 factorial into 2 factorial into 4. Fix P at the extreme left position, then the remaining number of letters are 11 factorial by 3 into 2 into 4 factorial. So that is 138,600. Now move on to the second condition. Do the word begin with I and end with P. So let us fix I and P at the extreme ends. I at the left end and the P in the right hand. So let us fix I and P here, I here and P here, right? So let us fix I and P at the extreme ends, that is I at the left hand and P at the right hand. We are left with how many letters? So 2 letters are gone, so remaining are only 10 letters are left. So therefore the required number of arrangements are 10 factorial divided by 3 factorial into 2 factorial into 4 factor, that is nothing but 12,600. So therefore the required number of arrangement is 12,600. That's it. Okay, hope you followed. This is how we are going to solve this problem. Now move on to the next problem. Yes, state and prove binomial theorem for positive integer n. So prove that for every positive integer n, a plus b to the power of n is equal to nc naught a to the power of n plus nc1 a to the power of n minus 1 into b plus nc2 a to the power of n minus 2 into b square, etc. nc n minus 1 a into b to the power of n minus 1 plus nc n b to the power of n. So this is nothing but the binomial theorem. State and prove binomial theorem for a positive integer n, right? Now, so this can be done by the method of mathematical induction, Now, so let us prove this theorem by the method of mathematical induction. What is given? Let P of n is equal to a plus b to the power of n, that is given nc naught a to the power of n plus nc1 a to the power of n minus 1 into b plus nc2 a to the power of n minus 2 into b square, etc. nc a n minus 1 b n minus 1 plus etc. The last term is nc n b to the power of n. Just prove by the method of mathematical induction means let us prove the statement is true for some positive integer n is equal to 1. Again prove that it is true for some positive integer k, which implies the statement is also true for k plus 1. P of k is true implies P of k plus 1 is also true. That is the method of mathematical induction. Now let us prove for the integer n is equal to 1. For n is equal to 1, put n is equal to 1 on both sides of the equation LHS and RHS. P of 1 can be written as P of 1 is a plus b to the power of 1. If we simplify this, so what we are going to get is a plus b. So a plus b is equal to a plus b. LHS is equal to RHS because RHS is 1c naught a plus 1c1 a 1 minus 1b. So 1c naught is equal to 1 into a is e. Again a to the power of 1 minus 1 is a raised to 0 is 1 into 1 is 1. So a plus b, LHS is equal to RH. Therefore P of n is true. LHS is equal to RHS. Therefore P of n is true for n is equal to 1. That means P of 1 is true. So the given statement is true for n is equal to 1. Now let us prove the statement is true for some positive integer n is equal to k. Let us assume P of k is true for k which belongs to n, for some positive integer k which belongs to n. Now that is a plus, just replace n by k. A plus b to the power of k is equal to, instead of n, kc naught a to the power of k plus kc1 a to the power of k minus 1 into b plus kc2 a to the power of k minus 2 into b square, etc. The last term is kck b to the power of k. So this is a plus b to the power of k, right? Now let us represent this as equation number 1. Just to prove that this is also true for k plus 1, just multiply both sides of this equation by a plus b. Now let us multiply both sides by a plus b. What we will get? So here a plus b to the power of k into a plus b is equal to a plus b into this entire term. So this is nothing but a plus b to the power of k, and this is a plus b to the power of 1. According to law of indices, a plus b to the power of k plus 1. So that is a plus b to the power of k plus 1 is equal to a plus b into, just multiply each and every term by a and then b. So what we are going to get? If we multiply by a, so we will get k, yes, kc naught a to the power of k into 1 is k plus 1. kc1 a to the power of k minus 1 into b, minus 1 plus 1 gets cancelled, we will get a to the power of k. So similarly, if we multiply with b, so kc naught a to the power of k into b, kc1 a to the power of k minus 1 into b is b square, so on like that. So Then just since this can also be written as, if you simplify, you're going to get kc naught a to the power of k plus 1 and group the terms which containing the coefficient of b, b square, etc., b to the power of k plus 1. So that is kc naught a to the power of k plus 1, kc1 plus kc naught a to the power of k into b to the power of 1. Similarly, that is kc2 plus kc1 a to the power of k minus 1 into b square, etc. Since this can also be written as k plus 1 c naught a to the power of k plus 1, k plus 1 c1 a to the power of k into b, etc. Since using the concept k plus 1 c naught is equal to 1, kcr plus kcr minus 1 is also equal to k plus 1 cr, and kck is equal to 1, that is also equal to k plus 1 c k plus 1, ncn is equal to 1. So using this formulas, if you substitute here, so this implies p of k plus 1 is also true. So thus p of k is equal to 2 implies p of k plus 1 is also equal to 2. Therefore, hence by the induction, the statement p of n is true. P of n is true for n is equal to 1, and p of k is true implies p of k plus 1 is also true. Therefore, p of n is true for all n belongs to n. This is how we are going to verify this binomial theorem by the method of mathematical induction. That's it. Okay. Hope you followed. Now, move on to the next problem. Derive the formula to find the distance of a point P x1, y1 from the line ax plus by plus c. This is nothing but the length of perpendicular. So, length of perpendicular from ax plus by plus c is equal to 0. Length of perpendicular to the line A from x1, y1. So the length of perpendicular, you know the formula for length of perpendicular is ax1 plus by1 plus c divided by root of a square plus b square. That's all. This is what we are going to derive. So for this we are going to consider the area of a triangle. Now let us consider, this is a construction part. Let P x1, y1 be any point whose perpendicular distance from the line is d. Let us draw the diagram. Let us draw a line. Let a line L cuts the x-axis at q and y-axis at r. Let a line L cuts the x-axis at q and y-axis at r. So that is, let the line ax plus by plus c is equal to 0 is a line which cuts the x-axis at q and y-axis at r. Let P x1, y1 be any point on the line, any point whose distance from P to M is d. Pm is the perpendicular distance. Pm is equal to d. Now, so to find the coordinates of q and r, now put when x is equal to 0, if you put x is equal to 0 in this line, then this becomes 0 plus by plus c is equal to 0, by is equal to minus c, y is equal to minus c by b. So therefore, the coordinates of y-axis is when x is equal to 0, y is equal to minus c by b. 0, minus c by b. Similarly, if you put y is equal to 0, on the line, this ax plus c is equal to 0, x is equal to minus c by a, minus c divided by a. So therefore, the coordinates of q is minus c by a, 0. Now let me explain in detail. Let P x1, y1 be any point whose perpendicular distance from the line is d. Perpendicular distance from the line L is d. Let the line meets the x-axis and y-axis at q and r. Therefore, the coordinates of q and r, q is minus c by a, 0 and r is equal to 0, minus c by b respectively. Thus, the area of the triangle PQRS is given by, just find out the area of the triangle. Area of triangle PQR. So, the area of the triangle PQR is given by, area of triangle is half into base into height. Half into base is PM, height is equal to QR. So, cross multiply it, PM is equal to 2 times area of triangle PQR divided by QR. This is equation number 1. Now, what is PM? PM is the perpendicular distance. PM is the perpendicular distance. So, the perpendicular distance is equal to 2 times the area of this triangle divided by the distance from P to Q. Just to find out the distance, use the distance formula, and to find the area, use area of a triangle formula. Now that is, now area of triangle PQR is equal to half into base into height. Now just to find the area of a triangle, now to find the area of a triangle, area of triangle PQR is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is equal to half into, what is x1? x1 is x itself, into y2. What is y2? y2 is 0 minus y3. y3 is equal to minus c by b, minus and minus becomes plus c by b. Again plus x2. x2 is equal to minus c by a minus c divided by a into y3. y3 is equal to y3. x2 into y3. y3 is minus c by b. y3 minus y1. What is y1? y1 is y plus x3. 0 into any number, you will get 0. So this is equal to half of multiplied. So that is cx divided by b minus into minus plus c square divided by ab and minus into minus plus cy c into y divided by c into y divided by a. So put it in order. This can be written as half into x1 into c by b plus y1 into c by a plus c square divided by ab. That is what I have written, right? Now, so therefore 2 times area of triangle is equal to 2 times area of a triangle. 2 and 2 gets cancelled. We can take this can also be written as, you can take c by ab common factor, and what is left is 1 by 2 into, so bb gets cancelled. We have a, that is nothing but ax1 plus aa gets cancelled. We have by1 plus c square by ab. In this we have taken ab and c. What is left over is c. That's it. So this can be written as half of c by ab out, and 2 and 2 gets cancelled. So if you substitute here, area of a triangle is equal to, so substitute here 2 times 2 into half of this, 2 and 2 gets cancelled. We will get c by ab into ax1 plus by1 plus c divided by ax1 plus by1 plus c. Now just to find the distance from q to r, that is using distance formula, qr is equal to root of x1 minus x2 whole square plus y1 minus y2 whole square, 0 plus c by a whole square plus c by b minus 0 whole square is equal to, just you can take c by a b common factor, x a square plus b square. So substituting these values in this equation, so in the equation we will get, in the equation number 1, what we will get? So pm is equal to c by ab into ax1 plus b1 plus c divided by cb. So these two gets cancelled. So what we have, ax1 plus by1 plus c divided by root of a square plus b square. This is the formula for perpendicular distance. That is, the perpendicular distance d of a point from the line to the given point is ax1 plus by1 plus c divided by root of a square plus b square under mod. That's it. Now move on to the next problem. Prove geometrically that limit extends to 0 of sin x by x is equal to 1, x being measured in terms of radians. This is also very important. Now for this, let us consider a circle. This is, consider a circle with O as center and R is the radius. So OA is equal to R, the radius. Mark the point A and C on the circle such that angle AOC is equal to x, which is less than pi by 2. Then join OA, OC and AC. Now at A, draw a tangent to the circle. Now produce OC to cut the tangent at B. So produce OC to cut the tangent at B. Then CD is drawn perpendicular to OA. So CD is drawn perpendicular to OA. That's it. This is the construction part. If you observe carefully from the figure, we can write area of triangle AOC is less than area of sector AOC. Again, area of triangle AOC is less than area of sector AOC, which is less than area of triangle AOB, which is less than area of triangle AOB. Okay, now just find out the area of triangle AOB, sector and AOB triangle. Now that is equal to, now area of triangle AOB for area of triangle AOC, area of triangle AOC is equal to half into base into height. Half into base is OA, height is CD. OA into CD. So this is equal to half into R into, consider this triangle from just, since CD is drawn perpendicular to OA, from this triangle COD, find out sin x. Sin x is equal to opposite by hypotenuse, that is CD divided by OC, right? So that is nothing but CD divided by OC is equal to the radius, cross multiplied, R into sin x is equal to CD. Substitute here. So that is CD is equal to R into sin x. So this can be written as half R square sin x, first part. Similarly, the area of sector AOC is equal to, you know, area of a sector is half R square x, half R square x. Now find out the area of triangle, area of big triangle. What is a big triangle here? Area of triangle AOB. Area of triangle AOB is equal to half into base is OA into height is AB. Now just from this triangle find out tan theta. What is tan x from this? Tan x is equal to opposite divided by adjacent, that is AB divided by OA, cross multiply, OA tan x is equal to AB. What is OA? R tan x is equal to AB. Substitute here. So OA is half into R into AB is equal to R into tan x. So this is equal to half R square tan x, right? Substitute this in equation number 1. So what we will get, that is area of triangle AOC is less than area of sector AOC is less than area of triangle AOB, means that is half R square sin x is less than half R square x, which is less than half R square tan x. Now you can divide with the common factor, divide by half R square. So what you will get? Sin x less than tan x. So this can also be written as sin x less than tan x is nothing but sin x by cos x. Now divide by cos x. If you divide by cos x, sin by sin gets cancelled, 1 less than x by sin x, which is less than 1 by cos x. Now reciprocate it. If you reciprocate it, you know A is less than B implies 1 over A is greater than 1 over B. So if you reciprocate, 1 is greater than sin x by x, which is greater than cos x by 1 is cos x. When x tends to 0, now 1 greater than sin x by x greater than cos x. When x tends to 0, cos x tends to cos 0, which tends to 1. Sin 0, 0, cos 0 is 1. So therefore 1 is greater than sin x by x, which is greater than 1 when x tends to 0. So therefore sin x by x lies between 1 and 1. This can be written as, therefore the limit x tends to 0 of sin x divided by x is also equal to 1. That is called the sandwich theorem. This is called the sandwich theorem. So limit x tends to 0, sin x by x is also equal to 1 when x tends to 0, where x is measured in terms of radians. That's it. This is how we are going to solve this problem. Okay. Now move on to the next problem. Find the mean deviation. What is to find? Find the mean deviation about the mean for the following data. Xi given, Fi is given. Xi is 2, 5, 6, 8, 10, 12 and Fi is 2, 8, 10, 7, 8 and 15. So put it in a regular form. So construct the table for this first. So Xi and Fi. Xi is 2, 5, 6, 8, 10, 12. Fi is 2, 8, 10, 7, 8. Add this. If you add, how much you will get? So if you add sigma Fi is equal to 40. Now sigma Fi is equal to 40. Multiply these two. So 2 into 2, 4, 5 into 8, 40, 6 into 10, 60, 8 into 7, 56, 10 into 8, 80, 12 into 5, 60. Add this. So if I add sigma Fi xi is equal to 300. Okay, sigma Fi is equal to 40, sigma Fi x is equal to 300. Now find out the mean. So mean is equal to mean x bar is equal to sigma Fi xi divided by n. So that is 300 divided by 40. 300 by 40. What is this equal to? 7.5. So x bar is equal to 7.5. Xi minus x bar. So xi minus x bar, mod of xi minus, what is x bar? X bar is equal to 7.5. So just subtract xi minus 7.5. So under mod. So that is 2 minus 7.5 is 5.5, under mod negative. So that is, I write one value, 2 minus 7.5. That's equal to minus 5.5. Modulus of 5.5 minus is plus 5.5. Again similarly, 5 minus 7.5 is 2.5, 6 minus 5.5 is 1.5, 8 minus 7.5 is 0.5, 10 minus 7.5 is 2.5, 12 minus 7.5 is 4.5. Now multiply these two, Fi into these two, multiply this. If you multiply Fi into xi minus x bar, what you will get? 2 into 5.5 is 11, so 2.5 into 8 is 20, 1.5 into 10 is 15. Then 0.5 into 7 is 3.5, 2.5 into 8 is 20, 4.5 into 5 is 22.5. If you add this, what you will get? Sigma Fi xi minus x bar is equal to 90. Just if you add this, if you add sigma Fi xi, so if you add sigma Fi into mod of xi minus x bar, this is equal to 92. So therefore, if I add sigma Fi into xi minus x bar is equal to 92. Okay, now therefore what is to find? The mean deviation is given by, therefore the mean deviation x bar is equal to sigma Fi into mod of xi minus x bar divided by n. So that's equal to 92 divided by 40, that's equal to 2.3. That's it. So 2.3. So the required answer, therefore the mean deviation x bar is equal to 2.3. The mean deviation. That's it. This is how we are going to solve this problem. Now move on to the last problem. A bag contains 9 discs from probability. Last problem is from probability. A bag contains 9 discs, of which 4 are red, 3 are blue and 2 are yellow. The discs are similar in shape and size. A disc is drawn at random from the bag. Calculate the probability that it will be a red, yellow, blue, not blue. So what is given? So n of s is given. Number of discs in a bag contains 9 discs are there. So number out of which 4, number of red are 4 and 3 are blue, n of blue is equal to 3, then 2 are yellow, n of y is equal to 2. So totally 9. So what is to find? A disc is drawn at random from the bag. Calculate the probability that it will be red first. Now first one, first one. So red, probability of red, P of r is equal to n of r divided by n of s, the sample space. Number of red are 4 divided by 9. 4 by 9 is the probability of getting a red disc. Okay. Next, second one. Second one is probability of yellow. That is nothing but n of y divided by n of s. What is n of y? number of y is 2 divided by 9. This is the probability of getting yellow. That is n of y by n of s is 2 by 9. Okay. Now probability of getting blue. Third one. Probability of getting blue. P of b is equal to n of b divided by n of s. That is blue. How many blue are 3? 3 divided by 9. That's equal to 1 by 3. Right. Now next. What is the probability of not blue? So, probability of blue is equal to 1 by 3. Right. Third one. Fourth one. This is third. Fourth. Probability of a not blue. Not blue. Right. So, that is nothing but P of B dash. So, P of B dash is equal to 1 minus probability of B. That is 1 minus 1 by 3. 3 minus 1 by 3, that's equal to 2 by 3. So, not blue is P of B dash is equal to 2 by 3. That's it. Okay. So, this is how we are going to find. So, probability of red is 4 by 9, yellow is 2 by 9, blue is 1 by 3, not blue is 1 minus 1 by 3 is 2 by 3. This is how we are going to solve this problem of a probability. Very important problem. So, hope you followed all these problems for 5 marks. So, here you have to answer only 4 questions. Each question carries 5 marks. 4 5s are 20 marks from part D. Right. Hope you followed all these 5 marker questions. So, you are going to answer only 4 questions. Each carries 5 marks. So, hope you followed. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.